Awesome. Good to hear. Well, good evening, guys. We're going to go into some pretty cool stuff tonight. JSON web tokens. We've talked about them before briefly. A few folks have asked about them, and I mentioned that we were going to be covering them in depth. And in particular, somebody was interested to know, how do they relate to cookies? And so we'll talk a lot about that. And I wanted to make sure that that the whole concept of cookies and the purpose of sessions and cookies is clear. So please ask additional questions if you have them, because it can get a little confusing. And I want to spend as much time as is needed to talk about motivation and purpose. Like why do we even have sessions and cookies and JSON web tokens? I keep wanting to call them JavaScript web tokens or JSON web tokens. And I think it's important to kind of understand the whole point and purpose of them, especially since there's a little bit of overlap in functionality when you consider cookies and JavaScript web tokens or JWTs, JWTs, a lot of people call them. And that can kind of make it confusing about which one you should use for which purpose, especially since you could use JWTs, for example, to manage sessions. And in fact, I think the link from the training kit for the Dig Deeper link, in fact, you can see my screen here. We've got, I think it's this one here, JSON web tokens versus sessions and cookies. Kind of gave me the impression when I read it that the author was suggesting that you could use JWTs to manage sessions. There are a number of reasons why you wouldn't want to do that. And in general, my advice is that you would use cookies to manage sessions. You would keep sessions on the server. And JWTs you would use generally for API authentication. It's a pretty narrow focused purpose. And so we're going to get into talking about what JWTs are. JWTs or JSON web tokens, and how they're laid out, and then we'll have a chance to work on how we create them and how we validate them. And all the example that we're using tonight as we go through the code doesn't really build on or use our session work from last time, and mostly that's just to keep the code clean and lean so that you can focus on understanding how these work. And it's pretty straightforward. I think you'll find it pretty simple. Probably, if I were to guess about what some of you might struggle a little bit with, it's just keeping in mind all the other stuff that we've learned. The concept of middleware and how that comes into play, and modifying the rec object and other things like that. And as I mentioned before, I know it could be a little overwhelming. You kind of feel fire hosed, but we're going to focus on JWTs. But any question that you have about previous sessions, or as we start to kind of wind up this back-end module, please don't hesitate to ask. I'm happy to dive into things. We'll have a little bit of extra time tonight to do that, I think. So let's take a quick peek at the project for this JSON web tokens module. Should not have clicked that. I think I have it open here. This is another two-parter. So after tonight, the first part of it will be adding, building an API with support for cross-session authentication using JWTs. And then the second part will be building a React client. That'll come after the next session. So it's another two-part thing. And what we're going to cover tonight should put you in a good spot to be able to do exactly what this part of the assignment suggests. And as it says here, your schema for your users adds another field that we haven't seen to this point. It's just a department field. As you consider data normalization and some of the stuff that we learned about that, you might consider that you would put departments in a separate table, and then use foreign keys to relate them to the users. But in this particular example, the instructions are careful to suggest that you don't need to go that far because it's not really part of the assignment. If you wanted to, it'd be fine. I think it's a good exercise, but the main idea is just to use a department value to group users, and then part of from a stretch problem perspective, part of what you'll look to do is make it so that when you request users, so you're logged in as a user, and when you request users, you only get back users that are in your same department. And so it should be pretty straightforward. And interestingly, doesn't really have anything to do with JWTs, except that if you wanted to expand it so that by default that's how it works, but you could give expanded permissions to somebody and represent that in the JavaScript or JSON web token, you could go that far as well. So this could be kind of a fun project that you can look forward to. All right, so let's talk about JSON web tokens. To kind of give an overview, and if you went through the training kit, then you saw this, but we'll just do a review of it. If you go to jwt.io and then click on the debugger link, you'll see a page that will allow you to enter or paste a JSON web token, and then if it's a valid token, it will decode it. And that decoding shows all the different parts that make up a JSON web token. And you can see the color coding here. The three components are the header, the payload, and then a signature. Unlike when we talked about when in previous sessions when we talked about the bcrypt module and creating hashes for passwords, we talked about how that hash is not an encryption of the password, it's just a hash. It's a one-way string of text that represents the password. In this instance, we are actually looking at not only encoded data, but there's some encryption involved. It's still a hash. The signature is still a hash, but it's like a salted. It's a hash of a salted secret. But in this case, we get to choose the salt. And so what that allows you to do. So in the case of our passwords, when we did the hash, we were hashing the password and then we added salt to it. In this instance, we're going to be hashing the contents of the header and the payload. And then we add a secret, which is like adding salt. What that does is it allows us to be in control of what the value of this hash ought to be, so that somebody in the middle, in particular the recipient of the token, can't change the contents of the token without being detected. So as an example, if you were to take the contents of this header and then the contents of this payload, we'll talk about the purpose of the payload here in a little bit. But if you were to take the contents of these two, combine them, and then add a secret, and then hash it using a hash algorithm, a secure hash algorithm, then later you could take the same contents of these two, add that same secret, run it through the same hash algorithm, and you should get the same value back. Okay, so that allows you to confirm that the data that you're hashing hasn't changed. Well, if you've been in possession of that data the whole time, of course it hasn't changed. But that's not the circumstance that we're going to have in this instance. If you think about it, the whole purpose of using JSON web tokens is to make it so that somebody can supply your server with credentials. And then once those credentials are verified, so it's a username and a password, and once they're verified as being accurate, the server will create a JSON web token and give it back to you. Okay, and that JSON web token will consist of a header and a payload, and then a signature that was generated from that header and that payload, and a secret that the server knows. But when the server gives you back the token, you don't know what the secret is. All you know is what the contents of the header and the payload are, and then you have this hash. Very often when systems use JSON web tokens, this payload part here will include what are known as claims. And claims are basically just key value pairs that describe something. And it could be describing the user or a combination of the user and the system. And those claims can specify what capabilities that user has within that system. The danger in that is that if you take this token that has all these claims in it and you give it to the user, you might think, well, the user or the user's application, or even a hacker who's managed to infiltrate the user's system, can just change the claims and just say, this claim says that you can read data, but you can't write to it. Well, you could just change that claim, and then when you send the token back into the server and make a request to do something, then the server would say, oh, well, this claim says you can write. The signature is what allows the server to verify that this data hasn't changed at all. Okay, because the only way that I can change the data and send it back in is if I also generate the hash. And the server is going to use its own secret that it knows that it used to generate the token to begin with in order to generate the hash that it's verifying. And if I don't know that secret, it's impossible for me to create a valid hash or a valid signature. And so that signature, all that signature does is allows the server to guarantee that the token that it's receiving, it is the same as the one that it issued initially. And so hopefully that's making sense, but I want to kind of step back just a little bit and talk a little bit about the overall setup and why we would even want to do this to begin with. And I realized after our discussion about cookies and sessions that this was a bit of context that we didn't talk about that might have been helpful to some if you found yourself a little bit lost with that. And the context is this: when you're writing server software, everything that we've been doing in class and during these lectures is, we write server code, and then we go into either a browser or to Postman, and then we do a test against it just to verify that it's working. But when you're writing a server application, you've got to consider that same server application could be receiving requests from multiple people. It could be dozens, could be hundreds, could be thousands of different people. And the problem that you want to solve is to make it possible for the server, when it receives a request, to know which of the 1,000 people have already logged in that request is from. And the reason why your server will need to know who that request is from is because they're all different, and they may have different capabilities, or they may have different pieces of data that you need to keep track of. And there's a number of different solutions to that kind of problem. And one of them we took a look at last time, and that is to create a session that's either stored in memory or stored in a database, and then to give the client an ID for that session record. And then we forget about it, right? It's been stored, and we're no longer going to look at it until we get a request in that has that ID, and then we'll look up that session and then basically pick up where we left off. But it makes it simple to create the server so that we don't have to think about or design some strange method for trying to keep track of who a particular request coming in is for, and what capabilities they should have, and what data they should have access to, and so forth. All of that stuff can be stored in the database and in a session, and is identified to us by the session ID that was in the cookie. Well, JavaScript web tokens or JSON web tokens, there I go again. JSON web tokens, help to solve a similar problem where when somebody logs in, we want to give them something that they can use in the future to continue to identify themselves. Instead of making the user continuously type in their username and their password, we can give them a token. This prevents them from needing to constantly type it in, or it prevents the client from having to have some way where the username and password are stored locally where they're vulnerable. These tokens that we create and we pass in, or that we give back to the user, are supposed to be given to us every time a request is made, and that allows us to validate that that the user should be able to do what it is their application is asking to do. And it is very tightly related to sessions, in that what we have in the database can be more than just authentication or even authorization data, but it can be transactional information about how the user has used the application to this point, and when they try to do the next thing, what should be the result of that. And I'm being purposely vague about what that could be because it really depends on what the application is. But the whole point behind all of this, again, is to allow the server to know who a request is from and to validate that the request should be honored. We're trying to reach that balance between security and convenience for the user. And so both sessions and session cookies, as well as JWTs, provide a foundation for being able to solve that problem. And together, they work pretty well. The tokens, typically, as I said, would be used to authenticate APIs, and the sessions would be used for managing sessions. The cookies, rather, would be used for managing sessions. And again, you'll find varied opinions around using JWTs to manage sessions. As I mentioned, I think this webpage at least gave me the impression that the author was promoting that, but there are plenty of others like this one, and I'll post this in Slack so that you can take a look at it when you have some time. He makes a very good argument, a very good case for why JWTs are not good for sessions. And I happen to agree with him. I think it's not necessarily a good thing. So we got a couple of questions here. Each user has a different session ID. That's correct. Otherwise, the server would have no way to differentiate between different users. They also have different user IDs, but we're not passing user IDs back and forth because the user ID is persistent. And whereas a session ID is, again, the word I've used before, is ephemeral, meaning that it comes into existence and then very quickly can go out of existence. And JWTs are also ephemeral. They have an expiration date. And the purpose for that is that we don't want to create security risks by having tokens and cookies lying around that can be used by anybody that happens upon them. They may find them if applications don't clean up after themselves well enough on the client side, which we can't control. We don't control the client environment. And people, a hacker may get something installed on a user's machine that can find old JWTs and old cookies, but they're old because they're expired and they're useless. They won't allow them to do anything anymore. Whereas if they were to find a user ID or a username and a password, those are longer lived and would be an attack vector. Okay. So back to JWT.io. Again, JWT or a JWT, a JSON web token, is a string of text that's encoded, and you should take care to know the difference between encoded and encrypted. It's not encrypted, it's encoded. It's encoded as a base 64 string, and it is 3 different pieces of information separated by a period. And here again, you can see they're color-coded. There's a header that specifies the algorithm that was used to create the hash. There's a payload that contains information that our application is interested in. including what the token is for and information we need about the subject of the token, which is typically a user, but it could be something else. And then the last part is a signature that we can use to validate that the token has not been modified. Because this data is just base64 encoded, it's possible for a client application or a user to modify it. And I'll give you an example of that. If I were to take this text, and I'll just find an online base64 decoder and paste it in here, and then choose decode, you'll see down here that just using that text, which looks, somewhat foreboding, that it's really not. It's, just by decoding it without any password or any secret or anything, we can get to the information that's in it. Okay. By the same token, we could change that information, right? So, for example, we can add. Let's say we wanted to add something to this. Maybe we think that would work, right? And if we were to take just this portion of it here and then encode it, we're going to get this string here. And I think if I were to paste that in here, then you can see that now I've created a token that has additional information in it that wasn't there when a token was given to me. So there's absolutely nothing stopping the client or the client application or client machine from changing the token before I send it back. And when I send it back, my purpose for sending it back is I'm going to be making a request and I want to send this token along with it so the server can validate who I am and what I'm supposed to be able to do and make a change. But even though I've changed it, you can see that now this application is telling me the signature is not valid. Okay, because this signature that is part of the token no longer matches the content. So that if I were to hash this data, I would get a completely different hash than this. Well, you might think, well, but the hash, that algorithm that was used, is known. It's right there. I can look that up as well and just apply the same algorithm and come up with a new hash. Yes, but understand that the hash is not just a hash of this data. It's a hash of this data plus a secret that's been added. And the secret's only known to the server. So while I can change the contents of this token, I can't get a valid signature that would fool the server into thinking that whatever I've added to the token is valid. Yeah, so you guys are getting a crash course in how hacking works. Yeah. Would the encoding be a formatting choice for later on rather than a security measure? So honestly, the whole purpose behind encoding is not to obfuscate or make it harder to read. It has to do with being able to transmit this text across an internet infrastructure that's unpredictable and might have components in it that are old. When you start to dig into how the internet is built, it's largely modern now, but it's a very, we'll say democratic, for lack of a different term, system where anybody can join it and become part of the routing infrastructure. And so being able to send data from one machine to another has to go through a whole host of routers and other machines that you don't own and you don't control. And they're on different architectures. Some of them are built on Intel, some of them are built on AMD, some of them built on, you may even have, old Sun machines, Sun Microsystem machines, or IBM AIX machines that are part of the internet infrastructure. And all of these different architectures have different bit sizes and different, byte size registers and whatnot. And there's an entirely interesting, to me, class of problem in that there's not a standard for how data is represented in memory. And some machines only support 7-bit bytes, and other machines will support 8-bit bytes. And trying to take a string made out of 8-bit bytes, 8-bit characters, and passing it through the internet across some server that might only support 7-bit bytes will cause it to be corrupted. By the time it gets to the other side of that old server in the middle, it's no longer valid. And so base64 encoding was a problem, or was a solution to that particular problem in a way, in that it allowed you to come up with a different string of characters that was compatible with a much wider variety of hardware. So encoding it with base64 is not really about aesthetics or about how it looks. It's not meant to make it unreadable. It's meant to make it transferable across an open internet that is very democratic's not the word I'm looking for, but very extremely varied. We'll put it that way. You bet. Hope that was helpful. It's kind of an interesting view into how that works. Base64 encoding, if you look into it, it's, if you've got 8-bit characters, one after the other, you essentially go through and take the first 7 bits and make that a character, and then take the 8th bit plus the following 6 bits and make that another character, and then take the remaining 2 bits and the following 5 bits and make that another character, and you end up with a completely different string. But it's just encoding. It's just a matter of how you choose to encode it, and you can decode it. Decentralized is a good term, Kenichi, but not quite the one I'm thinking of. But it is also representative of what the internet is. Okay, so what problem can you? So you can see here as I go mouse over the payload, it says, "Warning! It looks like your JWT payload is not encoded correctly." Using base64, and it's because I included this padding, which isn't necessary, and now that problem goes away. And that's another thing you'll learn about if you dig into base64 is that padding. But still, the signature is invalid, right? Question, can we say that sessions contain state? Memory, database, or cache, and JWTs are stateless with software validation through a secret. Ernesto, that's very well put and is very accurate. Sessions are stateful if they're on the server. Those that would advocate the use of JWTs to track sessions would say that you don't keep session data on the server, but rather you keep it in the JWT. And then as session data and information changes, the server would generate different tokens and send them back for the client to keep, so that the next time the client made a request, the server would have information about the overall session. It would be the same information that the server used or generated. It's just the server's not keeping it in memory or keeping it in its own database, but rather the server is sending it back to the client for the client to store, and then having the client send it back in. There are, when you get to internet scale applications, that could be very useful and is a potentially valid architecture, but this author here makes the case that when it comes to scalability, this one here in particular, this paragraph, he's saying that in general you'll find you don't really need that level of scalability. It introduces other challenges that there's no reason for you to have to try to solve. In fact, he says many easier ways to scale unless you're operating at the size of Reddit, which maybe you'd hope you were, but it depends on what it is you're developing and what you need there. Distributed ledger, interesting. It's a similar in concept. I don't know if I've used that word though. What exists to replace JWTs? I've worked on systems where we just created our own format. JWTs are just a standardized format. There are a number of other systems that I've seen. In fact, I read an article the other day about JWTs, where a guy just, he basically said they're not secure, when in fact really the only argument he was making is that there are many insecure implementations of the standard, but the standard itself is, if it's done properly, I should say if it's done well. His argument is that the standard's not written well, and if you adhere exactly to the standard, then you'll end up with insecurity problems. And I think he could be right about that, but most people, they're smart enough not to go there. But his solution was he created an entirely different standard, which is interesting. I don't know if it'll take off though, because this one is actually very widely used. Okay. Yeah, I put the link to the site up above, but Robert's posted it as well. Good. All right. Hopefully this has made a little bit of sense. It's been a lot of talking to this point, but the context of why we use these is really important, and I think it's important for you to understand and try to keep in mind as you're contemplating what's the whole point behind all of this. And it is that in addition, one of the things we'll talk about a little bit is that when your client application authenticates and gets a token back, very often you've got a system that's designed such that your authentication service is a completely different server than your API server. And so when you go to make a request to the API server doesn't have any way to authenticate a username and a password. The only way to work is with tokens. And that allows it to scale at a very well and very smoothly, what they call horizontal scaling, which means you can increase the capacity of your system just by adding additional machines as you go. Okay. Thank you. I'm glad it's helpful. All right. We are going to get to some code though, because that's actually my favorite part. But in the end, none of that's helpful if you don't understand why, right? All right, so in general, you're going to have a server, and right now, in our case, our server is both the API server and the authentication server, but generally you'll find that that's not the case. You'll have a different authentication process, and in fact, that becomes very handy if you want to leverage a third-party authentication system. So you'll create an API that will just work off of tokens, and you'll be able to get those tokens from a third party. And using something like JWT allows you to do that in a standardized way, so that you don't have to read some funky documentation about their homegrown format. That being said, I've worked on systems where we had homegrown formats and they still work. It's just a matter of what the overall design is and what kind of corners you're willing to paint yourself into. If it's a really comfortable corner, there's no problem with that, right? Okay. What I'd like to do at this point, so you guys have had a chance to kind of understand JSON web tokens, and we've gone through a bit of that. There's a library that is used to generate a JSON web token, and the documentation for that is in npmjs.com. Is it .com or .org? I think I called it .org before. .com. And the name of the module that we'll use, or the library that we'll use, is just called JSON Web Token. Okay, and it's this module here. And so you're going to want to add that to your project, and we'll kind of get started here, but then I'm going to turn it over to you guys and let you spend some time creating a solution. So this solution that we have, the repo for the guided project, is really simple. It's just starts a server. There's a couple of routers. We've got an auth router and a users router. And in our auth router, we have our bcrypt. So we're basically allowing users to register as we have before, pass in a username and password in the body to log in. And then once they've logged in, we're just telling them, hey, you're logged in. And then for future requests, this restricted. So if you come down and look at the users router, is pulling in this restricted middleware and using it as part of our middleware chain for the get/API/users endpoint. And what this restricted middleware is doing is pulling the username and the password out of headers and then validating them using bcrypt. Okay, so this is all old stuff. It's what we did when we talked about password hashes and whatnot. What we're going to want to do is replace this with a system ultimately that generates a token when they log in, passes the token back, and then expects a token on future requests. But to get started with, all I want you to do is create a new endpoint, a new method. You can put it right here in server that simply generates a token and passes it back. Okay, we're not going to store it. We're not going to make it usable. We're not going to check for its validation or anything. All I want you to do is create a method that will generate a token. Okay, so to kind of get you started, you're going to want to add the JSON web token package to your solution. And then once that's in place, if you look at the documentation for it, you'll see a particular method. If you've read through it, you've seen it already. And the method is the JWT.sign method. It takes a payload and a secret and some options. And so what I'd like you to do is just create an endpoint that when you send an API request to it, it just generates a token and passes it back. And whatever the payload is, you can make it be whatever you want. If you want to put something clever in there, and then maybe post your token, and then we can decode it and see what's inside it. Okay. A couple of questions. Why is the user's router using the middleware located in the auth router folder? Why not just have the middleware in the user's router? You could. I think that the reason why that particular middleware is associated with the auth folder is because it's middleware that is authenticating the request. And so you could go either direction with that. It's a matter of a personal style to some degree, but it's a good question. Okay. Yeah, and as Ernesto said, and Eric as well, you might want to use it in other locations. So auth is kind of a centralized place where that would work. Okay, so I'll put in this, let me just put this in. We'll say, okay, so that's the assignment, create a get endpoint that returns a JWT. And then we'll put 10 minutes on the clock and see where we're at after that. If you've got questions, feel free to weigh in, and we'll handle them there. Jimmy, you could put it in user's router if you want. That'll just make it so that the URL that you'll have to call would be /API/users/token. And if you want to put it there, that's fine. Or you could just do it right in the server file. So if you'll notice in the server file, we already have an endpoint here that's just get/. So you could just put it here and do server.get /token. Oop, I didn't mean to do that. It's not letting me. I'm trying just to put dots in there. Anyway, you get the point. So you can put it right there, and that'll make it easy. So you can just do a get/token. But if you want to put it anywhere else, that's fine as well. It's up to you. The main point here is to give you some experience working with the JSON Web Token module. So add it to your project, and then use it. Follow along in the documentation to figure out how to use the JWT.sign method to generate a token, and then pass it back as the result in the res.json method. That's right, Eric. Yes, you want to pass back a JSON Web Token. That's what that JSON Web, or if you're talking about the name of the package, no, it's JSON Web Token without the dashes. Yeah, Robert's got it there. No dashes. if you're a little bit lost, if I didn't make it clear enough, reach out to your TL, or you can private message me if you'd like, and we can get you squared away. Hopefully I didn't confuse anybody. This is a quick yes/no poll. If you could weigh in and let me know kind of where you're at, and it'll give me an idea of how close we are to being able to start. Please vote no if you're not ready to go. And if you do vote no, go back and change it when you are ready, just so I can have a good view of where we're at. So Izzy, is that just the payload portion of your token, or is that the whole token? Oh, that's, yeah, that's the whole token. Yeah, just Eric, return the token in the result. Okay, we'll take a quick peek here. Yeah, it doesn't look right, Izzy. I'm not sure. Is that what came back in your Postman? So Dave's got, oh, didn't use options, okay. The only option that I've used was expires in, so it indicates the amount of time before it expires. Okay, so Dave, there's yours. It looks good. Okay, still got a few folks working on it. If you got a token back, post it and let's just decode them, a few of them, and see how they look, and then we'll dive into the code. So here's one from Sammy. Oop. Bring that one over. Okay, is topic understood? Message received. I'll try to clear it out. Arthur's looks good. Okay. Okay, Ollie the best. That's good. Ernesto, you got yours. Good. All right. Let's dive into the solution here. If you're still working on it, kind of follow along and see if maybe this will be helpful to you. Okay. So what we're going to do, again, is we're just going to create a server.get, and what we're going to be getting is just a token endpoint. So I'm putting it in the server file, so it's not in a router that's bound to a default URL. Okay, and we want our homies here. Okay, and again, all we're going to be doing is making a call. So we know we're going to need to do a require here. And we'll require JSON web token. I just called it JWT. So we're going to need to create a payload. We're going to need to create a secret. And we're going to need to create an options object. And then ultimately, we're going to get a token by calling JWT sign. Okay, so that's the method that we're going to call. And you can see the signature says to pass in a payload. So I'm going to pass in my payload object. And then a secret. And then an options object. Okay. And then all we need to do is add it to the response. Okay, that should be all that we need. So in the payload, I'm just going to put in a subject and I'll put in a username. We'll call that Kirkby, and then favorite chili, habanero. Okay, and then our secret, we'll put in secret there, and then our options is just a string. And if you look at the documentation, they've got a pretty handy syntax for indicating an amount of time. I'm just going to put in 1 hour. Okay, so that should create all the 3 components that we need. And then just to verify, we'll just log it out. Okay, so let's see, a couple more. My error was not passing the payload as an object. Okay, so the token was empty. Ah, got it. Good. Izzy, I'm glad you figured that out. Yeah, the payload is an object. Okay. Douglas, you've got a thing here. Let's decode that real quick. Good. The dude. All right, so I've got a list of stuff here, and I'm going to start my server up. And then go into Postman. And I've already got my GET request here, localhost 5000/token. And then you can see I get my token here. And then if I were to go and decode it, you can see I get the subject, the username I added, my expiration stuff comes in to play, and then my favorite chili, okay, information. You'll notice that it says the signature is invalid. Why might that be the case? Why do you think it might be complaining about my signature being invalid? Wrong secret, Sammy. You're exactly right. It does not have the secret. It doesn't know the secret that I used. Okay. So it's a server that's owned and run by Auth0, which is a company. I'm giving them my token, but they have no way to create this same hash. What they do have is they have this text and they have this text, and they know the algorithm that was used. Okay. And you'll notice that I didn't set this. This was set by our library, okay, because it knows what algorithm it used, and so it was sure to include that for me. So Auth0 or this JWT.io website has all the information that I used to create the secret, or to create the hash or the signature, except for the secret. Okay. So it has no way to validate whether the signature is correct or not. Okay. All right. Let's see where we're at on time. I think it's time for a break. So we'll do that. We'll take a 5-minute break. I'll hang around if any of you need any additional help. Okay, server.js, we'll certainly bring that up. And here's my method here, all this green stuff here. So Kenichi asks, when we say that it takes the contents of the payload and hashes it with the secret, is it just concatenating everything and hashing it, or does it do something clever? It's not really doing anything clever. What it does is it base 64 encodes the content of the header, puts a period. Base 64 encodes the contents of the payload, puts a period, and then puts my secret, and then hashes that string. Okay, so Paul, you're confused about how to implement this in the doc. So when you look at the documentation, it's under this usage section, and it's the sign method here. So it's really just calling JWT.sign, passing in the payload, the secret, and then an options. We could also pass in a callback if we wanted to handle an error or not. One other trick that I often use, because sometimes documentation can be so it gives you an example here. I try to look for examples like this, right? So it shows that you've got to do a require on the module and then how to generate the token. And in this case, they're passing in just a payload and then just a secret. They didn't pass in any options. But this gives you an idea of how to do that. See how much time we've got left, a couple minutes. Okay, good job, Eric. Fire Ninja. Ooh. Good job, Jimmy. Okay, so Robert, you're asking what's the point of JWTs if you have a cookie? So the cookie is only going to contain one piece of information. Okay, so when we used the module that we did to generate and manage our cookies, the express-session module, the cookies that it generates only contains one piece of information, and it is the session ID. Okay, so when that module creates a session for us and either stores it in memory, which it does by default, or stores it in our database, which we could make it do through a configuration section, it creates a session and it stores it someplace. It gives that session an ID, and it puts that ID in a cookie that it sends back to the browser, so that when the browser makes another request, it sends the cookie which just has the session ID. That allows our server to look up the right session that matches that user. But there's no other information in it. It's only the session ID. We're making an assumption that the user is authenticated because we're assuming that they wouldn't have a session ID or if they hadn't logged in successfully. And to know which user it is, and by the way, this is a change I'll have to make to the code that I uploaded to the repo to kind of demonstrate the, not including the password in the session object, which was being stored in a separate database. Instead, I just used a field that said that you were logged in, but it didn't say who was logged in. There was wasn't storing the username or anything. So you do want in your session on the server side, you want the username because that's not stored in the cookie. All the cookie has is the session ID. When we're using JSON web tokens, they contain a lot more information, including information about a user and what permissions they might have, and other pieces of information that we may not want to manage on the server side. Let me turn off that timer. That we may not want to manage on the server side. And one of the reasons why where a JSON web token would come in handy more than a cookie is if you've got multiple services that are on different machines or running on different servers. In that instance, you want the client to be able to send a web token, because it can't control which machine that request is going to go to, or it may need to go to different services, and they'll all take the same token. If you were using a server-side session, then you'd have to create some kind of a shared session mechanism where they can all have access to it, which can be tricky and complicated. So there's a number of different uses for JWTs beyond what you can do with the cookie. In general, though, they typically both work together because, again, I've found and I believe that JSON Web Tokens are best suited for authenticating to an API, whereas session cookies are best suited for server-based sessions, which in terms of being able to reduce the amount of errors that you may have, I think are the best way to go. You could do stateless sessions where instead of the session information being stored on the server, the session information is stored on the client. And every time it makes a request, it gets another session object that has different data in it. That is another architecture, but it comes with a whole host of other challenges and problems when it comes to testing and scalability and security and whatnot that you probably don't want to tackle unless you have to. So I don't know if that answered your question, but I hope it does. Okay, so use the expiration in the payload instead of the option, which you can do. You can send emojis. Okay, so let's take a peek at this. Yep, there's an emoji for the username. That's awesome. Jimmy showed me a little while back that there's a VS Code extension for emojis. Yep, that's awesome. Okay, all right. Hopefully that we're kind of caught up to where we need to be. We're a little bit behind, but want to make sure you guys get the concepts here. All right, so the next thing we're going to do, so all we've done at this point is we've created an endpoint that just generates a token. We've not specified how the client should use the token, what the client should do with it, how it should send it back to us when we get the token back, or if any other server in our service were to get the token back, what's it supposed to do with the token? How does it verify it, right? And in addition to that, it's just an endpoint that generates a token. It's not tied to a user or a login. We've not validated who the user is before we generate the token. Right, so our next step is to, first of all, we want to create a token that we're going to send back to the client that contains information about the user so that when we receive that token again from the client in a future request, we can know exactly who the user is, and in a way that's trustworthy. And so where would we need to shift the creation of our token in our application in order to make sure that the user is who they say they are before we generate the token? Okay, so right now we've got it in a method, a handler that's just in server, but where would we want to put it? Okay, inside login, exactly right. You're going to want to put it in the login endpoint. So if we go into our auth folder and look in the auth router, this is where our login method is. Okay, and you can see that we're receiving a username and password, which we should do. That's the user has to tell us who they are and give us their secret. We'll validate them using bcrypt like we did before. Okay, but in here, we're going to want to create a token and then pass that back, right? So the if we look at our server, in fact, what I'm going to do is just split this to the right. Let me get rid of my folder list so it's a little easier to see here. If we look at our server, this is our code that generates our token. Okay. So what we're going to want to do is create a token and then pass it back. Okay. And we could take all of this code that we have here and just shove it here in our login handler. But it's already kind of messy to begin with. So what I think I want to do instead is I'll call a method. Okay. So maybe we'll call it gen token. And we want to pass in some data that would be our payload. Okay. We'll configure the options and mess with the secret in our method, but what we do need to pass in is a payload. And what's going to be different each time we receive a login request is going to be this user object, right? So we're doing a find by to find the user based on the username they passed in, and then when we get the user, we're going to use it to confirm that that the password is correct, and then we'll just pass in this user object to our new method. Okay, and then in addition to in the response sending a message, we can include our token, right? So now the problem is that we're saying we're going to use this method or this function, but it doesn't exist yet. So I'm going to go ahead and create it down here. Okay, and this method is going to take in a user object. So it's way easier to read in a try catch. Yes, if we did the async await syntax, I agree. I didn't mess with that just because I didn't have time, but I agree with you. And the question, wouldn't user include the password? Yes, it does. So that's a good point. Maybe what we want to do is just send in the username, right? If there were other information, we could create our own object and do that. But maybe let's just pass in the username, because that's a good point. Maybe we don't want to pass that password around like that. So in our generate token is just going to be a simple matter of we'll grab all of this and we'll bring it over here. And here we're going to say we want a payload, and our username can just be user. Or if we were to pass in the full user object, yeah, what did I do there? I typed the wrong. Yeah, let's pass in the full user object. Okay, so we're going to paste all this, and then in our payload, instead of hard coding a username, we'll just put in user.username. So that way our password doesn't end up being part of it. Okay, so we're just going to pass in the username, and then we've got our secret here and our options, and then instead of just creating and defining the token here, we're just going to return it. Okay, so again, all we've done is taken the code that we've used already to generate a token, and we brought it over here into our new method, which generates a payload, and it's using this information that we send in to make custom payload, creating our secret, creating our options, and then it returns the token. And so up here, we're getting that token, and let's add a little space just to make this a little more readable. And then when we do our result or response status, we're not only passing this message that says welcome, but we're also sending the token back. Okay. So let's give this a try. We'll save it. Our server's going to restart. Now, before we can actually try to log in, we need to register a user, right? So we've used this method before. We're going to call post register, and then we need to create a body, which is going to be raw JSON username. Then I'm going to be extremely insecure here and make my password. Not very imaginative tonight. Okay, so now if I register this user, then I should get the user object back, which I did. And now I can log in, right? So if I do a post to login and send the same body in that has my username and my password, what I should get back is a message and a token. Okay, so that didn't work. So let's find out why. There we go. Close that. We'll come over here. Let's just take a peek at our login. We'll just do a console log on our information there. And then we're going to check our token. Let's just try that. So if we do our login again, we're getting our username and password, but we're getting a 500 internal server error. So somehow we're ending up, oh, and it's because, let's see, find by username, which is S. Kirkby. And we did see that we registered. Let's just double check our database here. Go to dev, lambda, here, database. S. Kirkby is our username. There's a question, did you require JWT in the auth router? I may not have. That's a good question. Let's take a peek. I did not. That's the secret. So thank you. You caught my error, Joseph. So we'll do JWT equals require and JSON web token. Pretty sure that was the problem. Is that down here in the gen token, when we were trying to do this, it was failing. So we'll save our server and let's try our login again. And in this case, it works. So thank you. You got it. Don't forget to save. Thanks. I often do forget to save. So thanks for pointing that out as well. So here you can see we got the message and we got our token back, right? And if I were again to take this token and poke it into our decoder, and you can see we get the data that I sent back, just the username, not the password or anything else, right? Okay. So now we've got it so that we can authenticate the user, and we're sending information back to the client that in a token that includes who that user is. Okay, and again, to try to keep our code clean, we've modularized this. I'm going to take this console log out, and we're using this method down here to generate our token. Okay. Okay, so Jimmy, what you just posted is a bcrypt password hash, it looks like. Okay, all right, what's next? Let's see where we're at here. All right, so we've gone through that. Now, what we want to do next is we want to be able to validate the token. So let me give you guys a few minutes. I'm just going to do a quick yes, no. See if anybody's waiting to move on, please respond and let me know if we're good to go. Because we're going to dive into being able to read and verify the token next. So Kenichi asks in production, well, we want to put the secret in an end or something, and we do. We're gonna tackle that here in just a little bit. So that is, you've got a really good problem, because when we go to validate our token and we write code to do that, we're going to need the secret there as well. And we don't want to have it hard-coded in two different places because it becomes a potential location for problems. Okay, it looks like everyone's ready to move on. Okay. So the next thing, so we're going to capture that or tackle that in just a minute, Kenichi. So the first thing we want to do is we want to move on and make it so that once the client has the token, it can use it to send it back to us in a request. And it'll be confident that by including that token, we'll allow the request because we're the ones that generated the token. It came from us. And we can be confident that the client didn't change it or nobody changed it because of the signature, right? So all of that's handled by the JSON Web Token module that we added. We don't have to worry about any of the details there. If you're really bizarre, then you could dig into the details if you want, but no need to, right? All right, so as we take a look at our system, let me close that so we've got a little more space. Where do you think would be a good place to validate a token? Okay, so remember, we're generating the token when we log in, and we're sending it to the client. When the client sends the token back to us, we need to somewhere figure out whether that token is valid or not. Okay, so Dave says restricted endpoints. That's good. And middleware, that's correct. In the restricted location, right? So not all of our endpoints are going to need a token. We only want to validate it for those endpoints that that are restricted, that require authentication, that require us to validate that the user is who they say they are. Okay, and so that's where this restricted middleware comes into play. So if we look at our user router, then this is the one route endpoint that we have that is restricted, and it's using this restricted middleware method to do the restriction. So here's where we want to validate our token. Okay. So the way we're going to do that, I won't make the same mistake twice. I'll make sure that we include or require our JSON Web Token module. Okay. And so now we're in a position where we can validate it. Now this right now, this middleware is set up to pull the username and password out of headers, and because we're going to be passing a token back, we're not going to need that anymore, right? So this is the old way. I'm going to start with the new way. Okay, and the new way is going to retrieve the token that the client sends to us. What are some ways the client can send the token to us? Okay, rec.session.token. Robert, let me talk about that in just a minute because it's an interesting suggestion. In the JSON response, okay, the response is what we're sending back. So this is, we're going to get it on the inbound, okay, before we generate our response. Okay. Header or body, and the body, and the body, in the headers. Okay, so and then Dave suggests also local storage. We'll talk about that in a second as well. The correct answer is in the header or in the body. But keep in mind that we may want to or need to validate the token in HTTP requests that don't normally have a body. Even though they can all have one, it's bad form, for example, to put a body in a GET request. You can do it, but generally not it's frowned upon. So the body is not typically where we would want to put this data. You would want to put it in a header. Okay. Is middleware the place where we use next? Joshua, good question, and the answer is yes. You can see right here in our previous method where we were using the rec headers with the username and password. If our password check passed, then we would call next. So we're going to be doing that again. So good call. So let's go back to a suggestion Robert had made about retrieving the token in rec.session.token. Okay, so I just want to do a very brief review of the session object and how that works. If we had express-session as a module that we were using, if you remember, you require that module, and then that creates a method that we then pass some options into, and that returns a middleware method that we add to our chain, right? And typically we would want to add that to the chain for every single request. Because typically we would think that the session contains information that all of the APIs are going to need. And one of the things that we can do when in that middleware is when the request comes in, the session object on the rec object is created by the middleware for us. We have the option to adding additional information to that, right? And that makes it possible for that piece of middleware to make sure that certain bits of information are available to every other piece of middleware that might come in down the chain, just by adding stuff to the rec object. In this case, that's not what we're doing, right? So you would still need to do that in your application, but we've pared this down to just talking about JSON Web Tokens. And we want to be able to check the value of this token as soon as the request comes in. So we're assuming that the client has added the token to the request, and we're going to need to get it off the request, okay? And that's going to be done through a header. Now there's a standard, there's an RFC, which is an acronym that stands for Request for Comments. It's the RFC method of defining standards for the internet. Basically goes like this. If you have a particular standard you think should be part of it, you type it up into what's known as an RFC, or a request for comments. It gets a number, and then you put it out there, and then people can comment on it and tweak it and change it, and it goes through this whole process until it becomes adopted. And so there's an RFC that describes what you should do when it comes to authorization in HTTP methods, okay? And so there's a particular header called the authorization header, and then there are multiple authorization schemes that can be employed. There's one called basic, where you just include the username and the password in the header itself. In our case, we're not passing a username and password, so the scheme that we're using is what's known as the bearer scheme. And when we go back to Postman, I'll show you how that works on the client side. But on the server side, we should just assume that that they're going to take this token and add it to an authorization header. Okay, so here in our method, in order to validate the token, we need to get the token. And we're just going to pull that off of the request object in the headers collection. And it's just called authorization. Okay, and again, when we get to the client side, you'll see, because we're going to have to add that in order to make it work, you'll see how that works. Okay, so once we have the authorization, or the token, and just to make sure that it was included, we'll put it in an if there is a token, if it was included. Then what we want to do is verify it. Okay, so to create a token, we call JWT.sign, but to verify it, there's a method called verify. Okay, now to verify a token, you need the token. And the way that it's going to be verified is the verify method is going to generate the hash for the token. That consists of a hash of the header and the hash of combined with the body, and combined with one other piece of information. What else do we need to add in order to generate the hash? The secret, correct. So we need to pass in a secret here, okay? And I know from when I created what the secret was. Okay. And then we want to pass in a callback. So our callback is a method that receives two parameters. The first parameter is an error parameter, which verify will pass if there's a problem. And the second parameter is a decoded token parameter, which verify will pass if it's able to decode the token. Okay. So if our token and our secret passes muster and it's able to generate the hash or the signature and validate it, then what we'll get back is a decoded version of that token. Notice it's not decrypted. Again, it's decoded, okay, because it was never encrypted. It was only encoded. But in this case, it'll come back decoded, so we can access our payload, excuse me, without having to go through any process of decoding it. It manages that for us, okay? If we have a token, then we're going to, inside our callback, we're going to check to see if there's an error. And if there's not an error. Okay, so now we need to add some code. What are we going to do if there's an error? Well, we need to return an error response, right? And typically, if there's a problem with authorization or authentication, we're going to pass back a 401. And we're going to send back a JSON object. We'll send back a message. And we'll say, okay. Whereas if the token was properly decoded, we want to make it so that any other method that needs access to information in that token can get it. So, Robert, your question earlier about rec.session.token was interesting because we want to use that same method of being able to add stuff to the rec object here, right? So here we're going to call rec dot, and we'll add a property on rec, and maybe let's call it decoded JWT. And we'll save in that the decoded token that we got back from our verify method. Okay, so now we're in the section of code that determines that the token was valid. What do we have to do next? Somebody mentioned it, I think it was Joshua mentioned it earlier. What do we have to do now? This is middleware, right? And it successfully determined that, right, we need to call next. Somebody suggested I've got a typo. What did I get? Oh, decoded. There we go. Thank you. Yeah, fix your spelling error. I would have gotten there, but I'm glad you guys keep me honest with respect to this. All right. So yeah, so now we've got the token, we've saved it to our rec object, and now we're calling next. That'll allow the next middleware method to take over, okay? If there is no token, okay, we're essentially going to do the same thing, but maybe we'll have a special message. That indicates that they just didn't include the token, okay? That makes all of this other stuff that what we were doing before, validating by pulling the username and password off the headers and then hashing the password to see if their password guess was correct. We don't need any of this anymore, okay? Because now we're telling clients, if you want to use a restricted API endpoint, you have to pass a token. If you don't have a token, you need to get a token. The way you get a token is by logging in. Okay, so when you log in, you pass your username and password. We'll give you a token, and then anything else you need to do that's restricted, just make sure the token's included. And by design, we're saying that you need to include the token in an authorization header. Okay, so again, our method is going to pull the token off the authorization header. If there is one, we're going to call JWT verify using our secret so that it can be verified. And if that is wrong or goes bad, we'll return an error message. If it succeeds, we'll save the decoded token so that other API endpoints can use it off of the rec object, and then we'll call next. If they don't include a token, then we'll just return an error message. So Robert, you're asking at this point, what would a cookie be needed for? So again, what we're using this for is to authenticate the user for API endpoint usage. And again, I wanted you to kind of expand your thinking beyond the little test system that we have here. In the context of our test system, you could just use a session or the JWT. They both are kind of accomplishing the same thing, but you're going to have instances where you're going to need to use both. Sessions allow you to track information about what the user is doing and create some context or state around the application and how it should behave based on what the user's done before and what they should be able to do now. So it's really more about the functionality of your application. Whereas the JWTs are strictly about authentication and authorization, verifying that you are who you say you are and you can do what it is you're trying to do. Now, can you do all that with a cookie? You can, but when you consider a system that has multiple services on different servers, trying to manage all that through server-side sessions will get really complicated and could be pretty error-prone. Can you do it? You can, but it's not a great design. And so you want to keep sessions around for creating application state and context, so that that's how you can determine the meaning of what the user's trying to do. But who they are and whether they should even be allowed to do it is a completely separate question. And last time when we talked about sessions and cookies, we kind of used the cookie and the session to do both, right? We used it to confirm who you are and also to keep track of application state. So in this case, we're kind of separating out what the purpose of these two things is, and hopefully that makes sense. I realize it could be complicated, and I'm happy to maybe take some extra time and dig in for anybody or work together with the TLs and others that might be able to help you understand it, because it's an important concept, but I know it can be confusing. And a lot of what drives some of that confusion is that we're working in a really small system that's not distributed. It's not, not really designed to scale at all. And so you kind of get lost in understanding what the uses are. But the simplest thing I can tell you again is to keep this in mind, that JWTs are for authentication and authorization, and cookies are for tracking sessions that provide application state. Okay, so typically you don't want to mix those two. Yes, that's exactly right. That's why the guy wrote the article about not using JWTs for sessions. People do try to do it. They try to take, instead of using cookies and sessions, they use it, and some of them even extol the virtues, but there are challenges and problems. And in general, I think unless you have a really strong need for it, you wouldn't want to try to architect a system so that your application state is constantly being passed back and forth between the server and the client. But again, that will depend on the nature of your service. If it's a microservice architecture where you've got several different components that are running independently and they don't speak to one another, they're completely independent of one another, then in order for something that happens in one service to impact how something should happen in the next service, they somehow have to get information between them. And instead of creating a third service that just manages state that they can both track, what you can do is pass state information in a new token so that the next time a request goes to the other service, it understands what happened in the previous service. Keeping those services from communicating directly one to another is an important microservice architecture design decision. But yet you still have a need somehow to get state information between them. And that keeps your applications on the server side stateless. But that doesn't mean there's no state. It just means that they're not tracking state. The state is managed through passing through the tokens. And that's all part of what the session thing is for. So you can do that in tokens, but if your design doesn't require it, you're better off keeping the session information on the server and using cookies to manage that kind of information. Okay, so let me catch up on some questions here. Cookies track what you're doing and how, and JWTs ensure the right person is doing the right task. That's exactly right, Robert. I'm hoping that came from a position of understanding and not just repeating, because if you understand what you said there, you've got it. That's exactly right. You bet. silly question, but maybe a silly question, but how would this work if you have an auth server and an API server? So Eric, that's exactly the whole point, is that the authorization piece and function would be handled on the auth server. All it does is mint tokens. You give it authentication information, it gives you back a token, and then you should be free to interact with the API server or other services with that token. And those services will be able to validate not only who you are, but what you're able to do, and confirm that the token is intact and valid and hasn't been messed with, because presumably all the components on the back end have access to the secret, right? And there are public-private key encryption. So right now we're using a symmetric key where you use the exact same secret to decrypt or decode, or how do I put this? You use the exact same key to generate the signature on the receiving end as you did to generate the signature on the sending end. But if you use public-private key, then you can use a public key to generate the signature that then is verified with a private key. So that way you don't even have to share secrets across different services on the back end, but they can all validate who you are and what you're able to do without having to talk to one another or use a shared service. So, and a lot of this will come into play when you're just looking for good scalable designs that are easy to test, that are not prone to errors and problems and performance issues, which we haven't even talked about. And it's kind of interesting, we're talking about backend, but when you get into the computer science section and start talking about software architecture, then these things will come into play, and a lot of these tools will become really important to you. And then you'll understand, at a deeper level, why you want to keep your authentication and authorization separate from your session and state management, and why you might want to do that with server-based sessions versus client-based sessions. You've got options there, and you have to make that choice. And all the little testings and things that we've done here, it can all be server-based, it could all be client-based, it really wouldn't make any difference, but you will run into a situation if you're working on back-end where it does make a difference, and you've got to make a decision. Briefly reiterate when you'd use cookies versus sessions. I missed that part. So Dave, cookies and sessions are related. They're not exclusive. So you would use cookies and sessions. The session is a collection of information on the server side that describes the state of a user's interaction with the application. Okay, so it's just a chunk of information that the server would store that will impact how it behaves when the user interacts with the server again. So when the user logs in and then takes some action, for an example, the server may want to keep track of what pages you visited before, so that when you visit another page, it can modify what's on that page based on what you've done before. But in order to do that, it needs to know what you've done before, right? Well, all of that information would be stored in a session object, and that session, in our example, is stored on the server. What the cookie's for is, once the server creates that session and saves it, it creates an ID for that session record and sends it in a cookie, which basically tells the browser that, hey, the next time you come back, give me this ID, then I'll be able to look up your session and I'll know who you are and what you've done, right? So that I can control what should happen next. So cookies allow the browser to tell the server what session to look up and use. So it's not a choice of either cookies or sessions. If you're using sessions, you typically would use a cookie to have the browser tell the server which session applies. Hopefully that makes sense. Yeah, no problem. Hey, this is all, we're moving fast, right? So hopefully that helped. So Robert asks, how do we as devs create and store sessions? And the answer is, you could create that from the ground up if you wanted to. And a session is just a matter of having a data store and then tracking an ID for that session and relating it to a user, so that when requests come in, you'd have to write all the code to get the header from the request that has the cookie, that has the ID, use that ID to look up the session, and then also manage whether that session should still be active or not, whether or not it's expired. You can write the code to do all of that, and you can choose where you store your session information. If, as a developer, you would write a service that would maybe put it in a database or keep it in memory. But there's a module, and we worked with it last time, called Express-Sessions that does all of that for you, right? So you're not familiar with how to create the session because we didn't actually create them. It all happened behind the scenes in this module. And the way that it did it was we took that module and inserted it as middleware. So when a request comes in, it goes through that middleware function. And what that middleware function did was all that stuff I just described. It would create a session in our data store, create an ID for it, create a cookie on the response that has the ID, so that when we actually send the response back, it has the cookie in it that the browser would then store. The next time the browser would send that cookie in, that same middleware automatically looks for that cookie. Remember, we had to specify what the name of it is. Automatically looks for that cookie, takes that ID, pulls up the session information, and puts it on the rec object for us. You know, in short, if you were to create your own session management software, it might look exactly like Express-Sessions. I can never say that one right. I keep wanting to get my S's and S's mixed up. So the short answer is you can create your own system to create and manage session information, or you can use a module that manages that for you. And that's what we did last time, was we used Express-Sessions to manage it for us. It's getting hectic. Yeah, there's a lot to this. So hopefully this will be helpful. The recording. And do reach out to the TLs and to your SLs and others that can help out, that you have access to clarify this. When would you use something like Redis or Memcached? So basically what Redis and Memcache are they're basically stores that are super fast. It's all in memory, but it's also non-volatile memory. So it has the flexibility of a database with performance of memory. And so a lot of session management systems will use that. They're very good at handling information that is very ephemeral, information that comes and goes a lot. With database management systems, you've got to worry about fragmentation and other things that have to be managed, as well as performance, you know, of magnetic media. So Redis and Memcache are just methods for storing session information that they work very much like a database, but they have certain properties that make them attractive, especially in highly scalable situations. So Ryan's asking, the JWT.verify method always takes the secret and the token as parameters, and that's correct. It takes the token because it needs, that's what you're validating, but it can't validate it because what's in the token is a signature. And what it wants to do is similar to what we did when we used bcrypt to verify the hash of a password, right? With bcrypt, we had the hash in the database and we had the password. Bcrypt's going to try to rehash the new password or the password guess, and then compare the hash with the hash that we stored to see if it's valid. This is very similar, except that it's not just a hash, it's called the signature for a variety of reasons. But that signature was generated based on the information in the token plus the secret. And so what verify is going to do is regenerate the signature and compare it with the signature that's in the token. But in order to regenerate it, it needs information that's in the token plus our secret, because that's what was used to generate the signature that's in the token. So hopefully that helps understand that. Okay. I realize some of you are probably feeling, again, very much fire hose. I hope that rehashing this will be helpful to you. In the future, we still have a little bit more to go through tonight. But do, again, you know, use the other resources that are available to you. And again, it's all context. If you understand the why, it becomes very clear. The session and the cookies are related, and it's all about information that the application needs to do the right thing for a particular user. And it may make different choices based on different users depending on what they've done so far. Whereas the JWT is for validating you are who you say you are and you're allowed to do what you're trying to do. So they're two separate things. Yeah, those are funny. Okay. All right, so where are we at? Let's see. We're going through this. Okay, so just following through again with our middleware here, we're requiring our JSON web token. We're pulling the token off of the header, authorization header. Then we're verifying it by passing in the token and our secret. And then in our callback, if there was an error, we're sending back an error response. And if there was no error, then we're saving the decoded token on our request object so that other API methods, handler methods, or middleware methods can have access to it. And then we're just moving on to the next one. And of course, if there is no token, then we're just sending back an error response. Okay, so we have the server side of this done. Let's take a look at what happens on the client side. Okay, so here I am in my client. I've done a login, and I got this token back. Okay, so I'm going to save this token. And now I'm going to try to do a get on API users. Okay, now if I send that, what I get back is no soup for you. If you remember, this is what happens when we don't have a token. So it's trying to get the token off of a header, and because it doesn't exist, drops down here to the else and sends back this no soup for you method or message. So what we need to do is create a header. And the header name is just authorization. Okay. Now what I'm going to do is I'm just going to post the token in as the header value. Okay. Now normally you would actually use the bearer keyword, which I'm going to come back and do that here in a little bit. But I want to try to keep it as clean as I can. The idea here is that you're just going to take the token that you got before, and this would all happen in your client application. The JavaScript in your client would take that token and either store it in a local cookie or store it in local storage, so that when it makes requests, it's able to send that token. And tokens can live for days depending on the application and the service. We talked about that with respect to session value or timeout values as well, cookie timeout values. So here we've got our token, and we're saving it as a header. And so now I'm going to send this request in. Now you'll notice I get my response back, right? So this is the header that I sent in. And in our code, we pulled it off of the authorization header. Because it existed, we were able to drop into this part of our else clause. We verified it using the secret that was used to generate it to begin with. And because there was no error, it went down into this decoded, this else section where we saved it on the rec object and then moved on. To validate this, if I were to go in and modify this, let me just maybe delete a character and add a number. Okay, now it's an invalid token. And if I try to send it, then what I get back is this other message. What the heck? Okay, and that's what happens if this verify fails. We end up with this error object here. Okay. Thanks, Dave. I hope that was helpful, and I really don't want to leave anybody behind. So please speak up if you're feeling lost. So JWTs are more of a replacement of password hashes. What sort of data is usually included with them? Good question, and yes, I would say that is that is true. It's not really a replacement of password hashes, because you'll notice in our login method, in the auth router, in our login method, we're still using the password hash, right? So when we register, we still have to generate the hash and save it, so that later when someone calls the login endpoint and they use their username and password, we're able to validate it against the hash. But then what we send back is the token, and that prevents the user from having to ever send in their username and password again. So we only use the hash once, and that's in the login endpoint. Whereas before, we were also using it here in the restricted middleware. But once you get a token, and the nice thing about the token is that is two things with respect to security. One is that they have a limited lifetime. They'll eventually expire, which means if somebody gets a hold of one, they better make use of it now because it's going to eventually be useless. And you can make them last for seconds, minutes, hours, days, weeks, months, however long you want it. But you have to determine what it is it's protecting or providing access to, and how sensitive it is. So again, one benefit is that it can expire. The second thing is that we can force it to expire. If you've implemented properly, and we're not going through any of that here, but on the back end, you can, for any reason, maybe even allow the user to say, I want all my login tokens to be invalidated because I think I might be hacked. Even if it's a token that should last for a day, they can immediately invalidate it. So anybody that might have a copy of that token can try to use it, and even though it isn't expired, if it's been invalidated on the server side, then it's not usable. And that doesn't require the user to change their password. They're probably going to want to at that point, but that's a choice that they'll make. There's other use cases where using tokens instead of passwords is important, such as when you want to provide access to your account and your data to another service. And instead of a user getting the token, it's their service that gets the token. And then me as a user can eventually say, if I want to, I no longer want Facebook to have access to my information in this other system, or whatever it is. So tokens don't really replace the hash, but they allow authentication and authorization without requiring passwords to be passed back and forth. So we still need passwords, we still need the password hash, but we only need it once, and that's when there's a login. Okay, so boy, people are chatty. Let me come back. What data is usually included with them? So we talked about claims. If you go to, we're getting close to the end of time, but I want to take some time to just show you this. If you go to IANA, which is an acronym that stands for the Internet Assigned Numbers Authority, and they manage a number of different things that they're like the body that I remember we talked once before about early on about port numbers and how some of them are known as well-known ports. So if I look up well-known ports, for example, there's a port number registry that IANA maintains, and for example, if you look at 21 and 20 and 21. Those are used for FTP. 22 is SSH. 23 is Telnet. SMTP is 25 unless you're doing secure SMTP, which is 993. So they manage all this. But one of the other things that IANA manages is JWT claims. So inside the payload, you can put claims that use these claim names, and these are reserved for specific uses. That doesn't mean you can't use them. What it does mean is that if you use them, you can expect that the server that receives it is going to think that whatever name you used is for this description. Otherwise, you can generate any claim that you want, and the claim is just an assertion that says this user should be able to do this thing, or this information about that user is valid. This is their email address. So if I get a token that has my email address in it, and then I pass that token back to the server can be certain that that piece of information is valid, because if it's not, then the signature would no longer be accurate. So what information you put in it just depends on what your server needs. But here are some examples of some things that different applications might put in it. Okay, how would the user get the JWT without us manually adding it into Postman? So the user wouldn't actually get it, Robert, it's the application. So when we initially responded with it, when we did a login, our login method receives the token, or generates the token rather, and then sends it back. And the application would save that, and then on the next request, the application would need to include it. The user doesn't ever even see it. The user doesn't even know about it. All the user knows is I typed in my username and my password, and then I pressed click the login button, and then I clicked this button to show me a list of data, and it came back. What they don't see is that by clicking login, the credentials go to the server, and the server sends back a token, and then when I click this show me a list of users button, my application sends the token again. And then the server says, oh, okay, I know who the user is, and I know that they're allowed to get this, and here's the information they can see, and it sends it back. So it all happens on the client side in the back end. The user doesn't ever have to actually see it. So Dave got it right. The application stores it in a variable or in local storage. And what generates it is the server. Okay. Yeah, you guys are handling it well. So Robert, yes, I added it to the headers manually to show you what it looks like. Your client application would have to do that. Client application would add it to the header for every request that it sends in. So Paul says we're using hashing, cookies, sessions, and tokens. That's correct. So that's what we're kind of building on you know, as we go. So authentication is done with passwords. We've got sessions and cookies, which are related, and then now we're using tokens. So Robert, you asked why am I adding it manually, not why not get it from Postman since the server is set up. Postman displayed it to me, but Postman doesn't automatically add it to the header for my next outbound request. I had to do that myself. Can you update the JWT expiration of the user's active? Yes, that's a common thing to do. Actually, there's another mechanism where we're not going to go into, but you can look into it, called a refresh token. And it basically allows a secure way to get a new token when an old one expires without requiring the user to re-authenticate using a refresh token. And it requires a little bit of digging into to fully understand it, but that's typically how that would happen. But it's the same concept as what you described there. So I'm thinking JWTs are more like a user's profile. Cookies would be like their site preferences. That's a very good suggestion to think of it that way. Site preferences as well as, and keep in mind that the cookie doesn't contain information. In fact, neither the cookie nor the JWT should contain sensitive information of any kind. So profile information, yes, but only minimal that's needed to validate that the user is who they say they are and they can do what they're trying to do. You wouldn't put password information or other sensitive information in the JWT, and the cookie is only going to contain a session ID, which is then used by the server to look up session information on the server side. But that session information, let's see, you put in site preferences. I'm actually not sure I would use sessions for that because sessions are meant to expire and come and go, right? So session is really more about context and state of this instance of the user using the application. Once that state goes away, they'll have to re-log in and they basically are kind of starting over. If you want long-lived session information, then you can persist it for a long time or make it last for a while, or have some other method to turn it into preferences that you can then look up. But you're getting the concept. I think you kind of have the idea. Mentioned using sessions to keep track of user behaviors, but when you log out, the session is removed from storage. Then how do you keep track of the user preferences and behaviors if those records are removed? So preferences and behaviors don't really mean that in the context of like historical behaviors, but rather what have they done so far once they've logged in, right? So an example I mentioned is when a user logs into an application, they may go to this page first and then that page, and then this other page would depend on what they've seen before in this session, in this login session. But then if they log out or the browser crashes and they restart it and they start over, they may go to this page and then this page. And then when they go to this one, it's going to do something different. So it's really more temporary information about what the user's done in the app. And that was just a simple example. There are many other ways where you'd kind of want to keep track of what the user has done, maybe choices that they've made during the session that they would have to make again if they were to start over. Whereas permanent preferences kind of information, that kind of thing you do store in a database, and it's not really session-based. A session you can think of as the time between when a user logs in and until they have to log in again. So that during that period of time, session information should inform the application about how it should behave for the user based on what they've done since they've been logged in. And some of that stuff you may choose to save for a long time, so that the next time they log in, it's still active. And there are different architectures you can use for that, but sessions are really meant for information that is used by the application about the user since they've logged in. So these are things you'll have to ultimate, and I think that's why these projects for you are really good, because once you start digging into the project, then you'll start seeing context for why you would want to choose one thing or the other. And it's important now to be familiar with them, but you're not going to be experts about all of this and understanding it until you actually try to use it. And more than once, I've had a situation where, I had a question like, how would I or should I do X, Y, Z? And then it's like, well, I could do it this way or I could do it that way. Oh, I remember we talked about this, or I remember studying about this, or I remember reading that article that said that this was the better way, and I didn't understand it at the time, but now I get it because I'm in the middle of trying to solve this problem. So hopefully that that helps. You guys are swimming in deep water, but you got good floaties on, so you're doing great. We're out of time, and so there's one particular, it is pretty deep. There's one particular aspect that we didn't have time to get into, but I do just want to mention it if you can give me just a couple more minutes. And it is this idea that that we've got our secret hard-coded. Okay, so ideally what we'd want to do is make that be a configuration setting for the environment, and also make it so that we can read it either from an env or from a centralized location. So I'm just going to quickly, I don't want to do that. Let me come down here, create a config folder, and inside this folder, I'm going to create a secrets.js file. And essentially what this is going to do is export an object that contains our secret. And the value of this is either going to be something from our environment, or we can hard code it. Okay, and that's all that's going to be in this file. And then where we would use it, if we were to go back to our middleware here, as we would simply require that. So we could say require our secrets file, and then instead of this hard-coded place here, we can put in secrets.jwt secret. And then the other place that we did it was in our login, right? So up here, we would do the same thing. We'll pull in our secrets file, and then instead of hard coding this here, we will do secrets.jwt secret. So now, if we were to try to get our list of users again, well, actually, let me do a login. We take this thingamajig here, and then do a get. And then we can see we get our data back, because the token that was generated and the token that was verified used the same secret, and it got it from our secrets file. So hopefully that that makes sense, and it'll be in the code when I upload it. I will try to heavily annotate this. Give me a little time to get this posted for you guys, because And if there's some other resources that I think will be helpful to try to help understand the difference between sessions and cookies and JWTs, and understanding why you would choose one thing over another. One thing to keep in mind is that there might be heavily loaded opinions about what the right thing to do is in any given circumstance. And that might make you feel like that is the only right thing. But in the end, that's not necessarily true. And you want to get good jobs from companies that expect you to do things well. But you've got a lot of options, right? So a lot of what we're talking about are options. So when we talk about, should I use a session and a cookie or should I use a JWT, in some circumstances, it really wouldn't matter. And you can make that choice. And in other cases, you'll come to the conclusion really quickly that because of the way this is laid out, using a session and a cookie is not the right way to authenticate somebody. We need to use JWTs because it's going to work out way better. And it'll just make sense. Our little contrived examples that we have here, struggle to show that. So if you're having a hard time seeing why you would go one direction or the other, it's simply because you haven't had the context yet, and that will come. When you get into different projects, trying to solve different problems, you'll see how this all applies. But right now, it's muscle memory. So you're learning how to do it, maybe not necessarily fully understanding exactly why, but the time will come where you will learn to understand why you would want to do it one way over another. Strong opinions loosely held, good. So why is that showing the hashed password, and how would we remove that? And that's in Postman right here. Yeah, and that's happening, good call. That's happening because our get method, when we go to the user's router, is simply returning the user's object. If we wanted to change that, then we would create our own object that didn't include the password. Or if we wanted to, we could go into our database. Oh, it's not there. It's in our user's model, and just not return the password. So then the object won't include that. So if I go back here and do this again, then it'll only come back with the username. So we can choose what to send back or not. In that case, it was just configured. Somebody else wrote it to automatically return everything. So, all right, guys. I know you probably have a ton more questions. Hopefully you've seen I'm willing to jump on to Slack. So please hit me up there if you need some clarification. I'm happy to provide it. You've got excellent TLs. I see comments from them coming that show a great deal of both interest and ability to help out, and other resources and opportunities you have. So dig in. Don't be afraid. Try things. Try to break things. Try to learn from it. And we'll catch you in a couple of days. I hope you guys have a great night. Thank you.